So, in a just a brief description of what we make is we make spray painting and fluid handling equipments. So basically, we are a SPM manufacturer, and we manufacture all the components in house. So all the machining processes, the grinding process, selection, the drawing makings, castings, different types of material handling, everything is done in house. So as metallurgy is concerned, our product works at different temperatures, at different pressure ratings. Different material comes into contact at different weather conditions. So each field, I'll say, will give you a challenge to select the right material for making your product. So I'll give you a brief, short uh, decision points that or key points that we usually do while selecting a material for a specific product or selecting the component for that specific product. Basically, before a physically component is made, you should know where the component is going to be used. So with the end application and for what that product is being made. And before selecting the material in which it is made, will it satisfy all the design and application requirements? So basically, before selecting a material, I can say I have put up 5 key points. You should know the product, the actual application and requirement. Then you can list down a specific suitable materials that can fulfill that requirement. Once you list down that material in international standards or IS standards have physical and chemical properties, and depending on those properties, they are classified into a specific grade. So then you can list down a list of all available grades. Next is actual feasibility of that material and manufacturability. And obviously, in the end, cost factor and the material availability is an important part. Even if this is like a small tree, after selection of a material for a specific product, there is always scope for improvement. So even though the product is being made, it is fulfilling its application, you will always find a scope for improvement to betterment of that product. So then you will start again selection of new materials or greater material to upgrade your product. This is a continuous change that always happens. A simplest example. Am I audible?
Yes, sir, you are audible.
One second. Yeah. So as I said, we I classified it as five key points in selection of the material for making a product. So in description for those key points, first is knowing the product on application requirement. So it can be where the product is going to be used, how is going to be used, who is going to use it, the technical requirements, the physical chemical requirements, the work environment, the quality requirement, the actual life cycle of the product, and any other government regulations that can be need to be followed. So as I said, we usually list suitable materials that will be required to be made. So then, depending on the application and the chemical properties, we usually list down the materials. Like say, if I want to make a tap, I can make a tap of metal, I can make a tap of plastic. So that we initially list down the types of material that can be used. Later, from the list of that materials, we actually specify what grades are available. Like for say, if you have considered steel, steel comes in different grades depending on its purity, depending on the alloyability, depending on its chemical composition, depending on its physical properties that can be changed later, basically post processing. So basically, if I take a grade of say steel, some grades I can harden, some grades I can anneal, some I can plate, some I can coat. So basically, I can change its physical appearance of its mechanical or chemical property. So different grades of materials will have these different properties. So basically, we list out these grades of materials that can be post processed later also. Again, when you select a material, obviously we have to check if this feasibility and its manufacturability. Can the material be actually handled? Any specific tooling requirements you require? Will it satisfy your tolerance and design limits? Will it fall in this manufacturing process selection? The quality that will be achieved? Everything comes into consideration. And last, I'd say cost and availability, because obviously we will try to use quality and cost effective material, and that material should be easily available. And there are certain regulations while handling of specific materials in case they are reactive or explosive, etc. So as I said, we manufacture reciprocating pumps that are used for paint handling. So I'm taking as example of the piston of the pump and how we selected the material for it. Okay, so basically the piston of the pump, what is its requirement? It has to sustain high pressure and high stresses. So the pumps that we manufacture operate at around 350 bars. So the working pressure is 350. Obviously, the paint should not corrode the components. So the part has to be non-corrosive. The part should not erode off due to, since we handle liquids, there is possibility of corrosion and the surface might get eroded. So then it should fulfill that requirement. Again, since it is working at high pressures, it has to be tough and shouldn't break during operation. So we've got a standard of say it has to be hardened up to 40 HRC. Again, machining of the component should be simple. So the material has to be selected in such a way that machining is possible. Again, it has to be inert and not react with the material it comes in contact with. So now we are considering paint, solvent, enamels for a pump. So it has to be inert to those materials. So now, as we have listed down the product requirements, we come to a classification that the type of material that we can use is steel. So that is okay. We have selected steel. After that, we have seen a few list down of steels. Like we've got SS410, SS304, SS303, SS316. These are different grades of steels. Each steel grade has its own chemical composition, and as you can see, I've listed a few values for it: the chromium percentage, the nickel percentage, etc. So they give us they tell us how hard the material is, how non-corrosive the material is, and how easily machinable the material is. So knowing the chemical composition, you can check list the product requirements. Now, say if I these four selected materials all have chromium and nickel percentage, so they will be slightly non-corrosive. Since they have chromium and be percentage is less, the machining will be simpler. Since they have nickel and chromium percent, they will not react with paints and solvent. So they satisfy few of the product requirements. Again, the tensile strength, the yield strength, the chemical properties, the physical properties will define if it will sustain the high pressure and stresses. So again, it satisfies the product requirement. Basically, as I said, they satisfy the above requirements. Now, in the previous one, for this product, we have selected SS410. It has a good machinability. It is readily available. It can be hardened to a certain extent, and it satisfies the machining tolerance. But the major advantage of using SS410 above the other three materials is the option that it can be chrome plated. So chrome plating process is possible in that material, and because of chrome plating of a certain layer, the requirement of resistance to corrosion or cavitation is possible. That's thin 25 micron, 30 micron layers of chromium on the part will resist it from cavitation. So basically, I select a material that can satisfy all my specific requirements. Now, there is a case where this product can be used for a different application also. So there is a slight change in requirement. Instead of paint application, say I need to use it for a food grade or a pharma equipment, then keeping all its physical requirements and non-corrosive, it has to be inert to medicinal and food products also. In such a case, I will have to select a different material, that is SS316, where the nickel content is higher and it satisfies the above requirement of being inert to medical and food products. So depending on the actual requirement and chemical physical properties of the material, even at the end, the slight increase in cost will actually make you decide which material you should be using. So as you can see, the same product, we have made it in SS410 as well as SS316. It satisfies all the design requirements, the actual requirement, the function requirement, and also its specific application. Now, for this selection of material, it is important to know the properties of the material. We have selected two materials, say SS316 and 410. They have a small difference in its chemical properties. But knowing this difference in chemical property helps us select the actual material that is suitable for the application. As you can see, 316, the chromium percentage is higher. So it is more resistive to uh, being inert or non-corrosion. That, that's how the Sorry for the disconnection. Power cut. Yeah. So as I was saying, different chemical
Yeah, yeah.
composition of the grades helps us select depending on what application is using. Now, the grades of the materials that we have used, you can have actually more different material also. So we have considered only stainless steels, only steels. There is in a future application that we are doing is we are using material EN11B. Now this I'm not put it in this way because it is still under trial. In that it is its machinability is much more simpler. The hardness can be increased up to 60 HRC. It can be chrome plated again, and it is inert to most of the solvents. So basically, we can have a list of materials that can be used to produce a specific part, and the best selection, I would say, should satisfy all your requirements: design requirement, the application requirement, and obviously the manufacturing and cost requirements. Hello.
Hello. Yes, sir.
Yeah. Is there any questions and answers?
You're done with your
Yes. Yes.
presentation? Okay. Uh,
Do you want me to explain any other uh, application or different
yes,
selection?
yes. Is it, yeah, different selection. Is it possible? You can go ahead.
Mm, like now we handle aluminum grades for casting, forging, and machining. So even if you say aluminum as one grade, it has different chemical composition. So the aluminum selected for machining components is different. For casting is different. For forging is different, and for specific machine applications also is different. Like I can give you four examples. We are making a spool for say a dry slide. Over there, we can use normal regular uh, alloyed aluminum. For for a spray gun, we use a specific grade of aluminum, which is called as HE30. Now that grade of aluminum has a property that it can be hardened, and the case hardening is so good that after hardening, the machinability is not possible. So basically, you have a lightweight of aluminum and a hardness of almost like steel. Again, for casting, we usually use aluminum of LM grade. So LM20 grade is pure aluminum with hardly 1 to 2% of sulfur. So while castings, the percentage of sulfur is less. For forging, again the percentage of sulfur is less. The percentage of sulfur defines if the material will crack at hot temperatures or at high impact. Again, if the sulfur percentage is high, post process is not possible. So, like what do you call zinc coating or anodizing is not possible. Which one, sir?
Hello, Richard sir.
Yes, yeah, yeah. I'm just reading the questions.
There are certain questions on the chat window.
Yes,
Should
yes,
I
I'm
read
just
it
taking
for
that.
you?
No, no, I have it on.
Yeah.
Yeah, now
Nir-
for
Nirmala
coating,
Bhingare, madam. Yeah.
yeah, for coating we do not use PVD or CVD. PVD and CVD are usually used for, I'll say, iron components that are used in vehicles. Now, PVD or CVD are used for CVD is used for rust coating. PVD is used for more of for toolings. The coating that we use is hard chrome coat, and it is done by electrical deposition. So the components is dipped in a chemical chrome chemical solution, and electricity is passed, and it takes around 6 to 8 hours for around 50 microns of impregnating.
Okay, sir.
Uh, yes, and for weight of spray guns, there's an international standard called as ATEX, which is used for spray coating equipment. So there is a limitation for the weight of the spray gun and its safety measures.
Hello.
Hello, is my voice audible? Hello,
Sir, you
voice.
can stop slide sharing
Yeah, yeah, yeah. I'll keep
and
the mic.
you can put on your audio and video.
Yeah, fine. Yeah, fine.
Stop presentation.
Yes.
Yes.
Yes. Yeah, as I was saying, there is a limitation for the weight of the spray gun. There is an international standard called ATEX in which the specific requirements of pressure and safety is defined. And the weight for a standard spray gun has to be below 650 grams. Material specification sheet during testing of materials. Yes, any paint or chemical company will provide you with an MSDS, material safety and data sheet. So the material safety is the how to handle the material, and data sheet will consist of all the chemical properties, its viscosity, its density, its reaction time, its dry time, considering it is a paint, and we use it. And basically, the main feature that we use on that material data sheet is the type of application. So the type of application over there, they suggest that this paint will be sprayed at say 250 bar. So that is our basic reference. That reference we use for selecting the pump or specific nozzle size, depending on the pressure ratings.
As I said, the spray guns have a limitation for the guns. So the gun can be either machined, casted, or forged. But then the best process is to be using forging material, because in case of forging, you get that shape of the gun with impact, and the chances of having defects and blowholes is less. So it is more safer. And we we usually prototype model the initial gun sample to see that it uh, falls under that weight regulation. Even the machine gun body, there are certain blind holes or just dummy holes or some shapes given just for weight reduction. Uh, I'd say for metallurgy, uh, usually no one remembers the exact values of chromium, exact values of the percentage values of chemical composition. But then the processes that can be used to detect or the main properties of the metal is most important. Like say 303 steel is more machinable than 304, 410 or something like that. So I'd say best is to remember the actual physical and properties for material that comes in more handy during industrial work. Uh, the maximum chrome coating that can be got is around 1 to 2 mm. It takes around 12 to 18 hours. And plating is done just to increase the surface hardness. Chrome plating is a process where the surface hardness is increased. Similar thing happens in nitriding and carburizing, but in nitriding and carburizing, the metal diameter does not change. In chrome plating, you're actually adding a different type of material on top of the compound. Now, as I said, we have certain components that were hardened but toughened. After hardening, again, we do an annealing process and stress relieving process. Okay, I was in a Tata Motor employee for roughly around 2 years, and I was a new product development engineer over there. So I was in the engine division, and we used to develop sheet metal products for uh, fifth generation, sixth generation engines, Euro 5 engines basically. So over there we were provided with drawings from the design team, and we had to make prototypes and take trials of the components that were to be developed and be used for a vehicle. One experience that I remember is on your vehicle engine sump. The sump is made by hydraulic press, and the component is made. Initially, that was used. They used to use a grade, a steel grade. I don't remember the exact grade number. So they used a malleable ductile sheet that they used to use. From Sweden, there was a company that used to make a similar sheet, but of sandwich material. Basically, that sheet was a thin layer of sheet with a central rubber layer glue and another thin layer of sheet. So this they tried out this material. It was malleable. It could be formed into that shape. And the main advantage of that sheet, sandwich sheet, I'd say, was that it had the property of noise damping. So usually, if you see metal components, they do not have the property of noise damping. But this composite material of metal, polymer, and metal again was being used for noise damping. Usually, we consider it as for designing any component, we consider yield point. And in certain high safety components, ultimate tensile strengths are used, but generally yield point is considered. In VR coatings, I've been almost now 8 years. There is specific version of pump that I solely designed. Okay, and we since our pressure ratings, the maximum that we have won is around 700 bars, and the safety factor of safety, I say we consider 18. So since our factor of safety is pretty high, the weight of the component is very high. So a specific version of pump can be as heavy as 80 to 100 kilos. Now, since I said it's a pressure equipment, if go into design calculations, you can see that pressure vessels thickness will come up to 5 mm, 3 mm, 2 mm. Even boiler thickness for sustaining 100 bars is that thickness is pretty fine for a specific material. The cylinder part of our component can be up to 11 to 12 bars, and we design it for that safety, considering not only its bursting pressure for the yield of the material, but also this values modify, because we have certain heating applications where heating can go up to 100 200 degrees Celsius and the properties completely change. And if there is sudden cooling or sudden quenching of that part, the material hardness can change and the complete properties and the design failure could occur. That's why we have the thickness and factor of safety pretty high. For coating of marine applications, so usually it's a spray painting coating, and usually they use what do you call water grade paints. Now those paints are composite paints. They are PU applicating paints that can resist corrosion and erosion depending on what quality is used. There are certain paint what do you call manufacturers that actually give guarantee up to 5 to 10 to 15 years of what do you call it, guarantee that the paint won't erode. Now such paints are used in marine applications, also in hydro and oil pipelines. So if you have say IOCL or Reliance pipelines, they have their pipe of water line going through undersea or underground. These pipes are coated with a specific grade of paints that sustain this high wear and tear, high temperature, high corrosion resistance. PCCOE. In PCCOE, what skill? Uh, I I'll say I was in PCCOE campus for actually 6 years. I was 3 years in PCB diploma as well as 3 years direct engineering, 3 years in PCCOE. Initially for PCP, we had a lot of hands-on application. At third year, we actually had 3 to 4 industrial visits per week. And most of the practicals that we did, we had a lot of apparatus. And even if we didn't have the apparatus, we were asked to go to different colleges who have those apparatus. So I still remember for my boiler, we had this applied thermodynamics practicals, and our boiler wasn't working. We were asked to go to CUAP Pune to actually conduct those practicals. So my basic experience in doing engineering was that most of my practicals I had to do on my own because I was always busy in sports and busy playing, and eventually I used to end up last to do all my practicals. So I used to come during weekends and holidays to actually cover up all my practicals. in carbon fiber work more. We actually we are what do you call equipment manufacturers. Carbon fiber, we have only one protective guard that we use for a component that we get it manufactured from outside. Yes, but we have done paint trials and we provide equipment that are used for painting the carbon fiber. So we have equipment at Tata usually where all the carbon fiber, your front body components are painted. So we make equipments that are used for painting this carbon fiber. So we've got equipments in Gujarat and in Rajasthan that paint components for Pulsar and other two-wheelers. Coating is better option than heat treatment. It actually depends on what application you want. Now, heat treatment changes the physical and I'll say chemical properties to a certain extent. Like say if you heat iron, it will increase its hardness. It changes its chemical properties. And coating is done on top of the actual material. Your physical, chemical properties won't change, but you have a layer for protective measures or aesthetic method. So coating is done to change that. You either have protective measures or aesthetic measures. Even if you consider tooling, high-speed steel like drills and all that are coated with PVD. The PVD is just a hardness layer to increase the tool life, to increase, reduce its wear. Yeah. I think the latest trend now is not only selection of a specific metal for an application. The latest trend now is more composites. So that all the initial applications are trying to use composite materials for their applications. Like initially, car bodies were made by metal, now they're made by fiber. And you see, in your door panels, they won't use wood, they'll use specific grades of plastic and other composites. So by composite, I mean it's a mixture, it's a hybrid material. So the hybrid material is used for getting different kinds of chemical and physical properties that satisfy the actual requirement. Right now, for torsion application is as a shaft, I don't think composite material is most suitable. They still use alloyed metals for shafts just because I think one advantage is process is that it has a self-lubricating process. In the main disadvantage of composite material right now is self-lubricating is not possible.
Hello, ma'am. Nirmala, ma'am. Hello. Konda, sir.
Hello, sir.
Yes, ma'am.
Hello.
Ma'am, if there are no other questions, you can give
Yeah.
vote of thanks and we can wind up the session.
Yes, sir.
Sir, any last guidelines to the students before we go for vote of thanks?
I'd rather say, uh, rather than, I think my key point would be that rather than trying to, what do you say, just mug up technical details, you should try to understand why it happens. Because when you know how and why it happens, even if you don't know the actual specific values, it comes in handy in the future.
Okay, Nirmala ma'am. Hello, Nirmala ma'am.
I'd like to add one more point. Uh,
Yes, sir, please.
when we select a material for our product and then we set it out for manufacturing, before the actual product is manufactured, there is a technical process that is called as FMEA, failure mode effective analysis. In that, too, it's a complete analysis, a technical analysis of when and how that component might fail and at what process it may fail. So in that too, the actual design calculation values and the conditions are decided, and that also helps us in finding solutions of your selection of the material is right or not. And it is the most standard process in all OEM companies. If you go to any OEM company, each part that is made, you will find a file that has this FMA process. It defines you its complete process flow, its failure analysis, and its risk of using that specific component.
Hello, ma'am, you are there?
What?
Yes, yes. Can I give vote of thanks?
Yes, yes, please go ahead, ma'am.
Okay. On behalf of Department of Mechanical Engineering and all our students, I want to thank Richard sir for giving his valuable time for explaining students about importance of selection of material for industrial application. Students have learned many things in metallurgy like surface modification methods, corrosion prevention methods, as well as heat treatment processes. But today they got actual how we are using that knowledge into application purpose. Means only getting knowledge is not sufficient. That implication of that knowledge is important. So that idea our students have got. And also I thank all the students for active participation. I thank Dr. Vijay Kumar Jatti for arranging such a wonderful session for our student. And lastly, I thank you Richard sir once again, and we'll be in touch. All our students will be in touch with you for further guidance in metallurgy or in their career field.
Yeah, thank you.
Yes, sir. Thank you very much, sir.
Thank you.
And I conclude the session is over now. So thank you.
Ma'am, instructions.
Instruction for day one activity.
Yes.
Yes. Yes. So instruction for all the students. The link will be shared with you for activity of day one. All students have to complete that activity on Moodle of your respective metallurgy subject. For division wise, you have one metallurgy link for Moodle. For division A, it is separate, B separate, and C separate. So your respective subject faculty have put day one activities there. They will share link with you. So all of you have to solve that activity and post your answers there. So we'll observe and grade that answers, and on last day of this workshop we'll give you certificate based on that activities. But remember, for getting certificate you have to attend all the sessions on 6 days and all activities of 6 days. Thank you.
Yes.
Okay.
Yes, then officially we will conclude here then.
Yes, sir. Thank you.
Thank you.
Thank you, Richard sir.
Thank you.